Everyone, welcome back to Everything Swift. Today we'll be tackling LeetCode question 141 titled Linked List Cycle. We are given a linked list and the head parameter here, and we're supposed to find out whether this given linked list here has a cycle inside there. Let's take a look at this example. We are given this linked list via this parameter here, and we're supposed to find out whether there is a cycle. In this example, it does have a cycle, as we can see here, right? There is a cycle in the linked list where the tail connects to the first node, 0th index. So this is the first node because this is 0 index, this is the first index. But basically, that's why they call it the first node, referring to this node, right? So there is a cycle here where this POS or position here is pointing to 1, right? So there is a cycle basically, right? And then in this example here, POS is 0. Basically, the tail is pointing to 0 here, and that's why there is a cycle here. There is a cycle in the linked list where the tail connects to the 0th node, which is the real first node essentially of the linked list. And then in this example 3, we can see that there is only one node and the POS or position is equals to -1, so there is no cycle here. And also theoretically, I think if you have one node, technically there's no possibility to have a cycle because there's nothing to point to, right? So looking at these three examples here, I think it's fairly clear what we are supposed to do today. The question is how we are supposed to do this, right? So just a quick tip, like whenever we are dealing with linked list cycle or detect whether there is a cycle in the linked list in other questions and stuff like that, we want to pay attention and to keep in mind that we are supposed to use Floyd's cycle detection algorithm, right? So there are ample of resources out there that does a better explanation of Floyd's cycle detection algorithm. So please go and check that out because they have quite a detailed algorithm where they have mathematical solutions to prove this algorithm actually works in terms of detecting cycle detection. But the summary here is that Floyd's algorithm, this cycle detection algorithm, is consisting of two parts, which is the first part is basically to prove that it has a cycle, right? Which is the only thing that we are supposed to do in this question. We are only doing like the first part of this algorithm. But in the more complex question, the second part is basically to find out the starting point of the cycle. So in this question, we are not supposed to do the second part. We are only supposed to sort of like find out like whether there is a cycle. So this is only the first part of the Floyd's algorithm. And as I said, it's pretty complex. If you guys are interested in the math theoretical thing to prove that this algorithm works, please feel free to check out some of those online resources out there. But just to keep this video concise enough, we are using a Floyd's algorithm and we are only doing the first part. But yeah, so let's get started in the coding part. As always, I'm just going to check for quick optimization here. If head is nil, basically I'll just return false. There's no cycle because there's no linked list to begin with. And as always, in the world of LeetCode, unless specified here, this case probably would not happen, but it's just a habit of mine in the real world scenario where parameters of optional can be nil, right? So I'm just checking this, and if it does happen, it will just exit this function as soon as possible. So just a tiny bit of performance gain here. So now the Floyd's algorithm here, cycle detection algorithm, is basically uh, based on this concept of using two pointers of representing fast and slow pointers, right? So the idea here is that the fast pointer will travel through the linked list 2 times faster than the slow pointer. So what happens is that once this cycle is being run, the slow pointer and the fast pointer is being iterated through. If there is a cycle, basically the fast pointer will actually meet the slow pointer eventually. So that's how it works, right? So I'll show this in code. I think it's a bit more clearer to see like what I mean by the fast pointer traveling 2 times faster than the slow pointer. So I'm just going to set up the slow pointer, which is pointing to the head, and then the fast pointer is also pointing to the head. But what we're going to do now to check is basically while fast is not equals to nil and fast.next is not equals to nil, we're going to keep traversing this all the way until it's not nil. Right? As long as it's not nil, the fast pointer, we're going to keep this alive. And this is what I mean by fast pointer traveling 2 times faster. So slow throughout this iteration here will only travel one link list node at a time. So it's just going to be next node, next node, next node. But the fast pointer will go 2 times faster, which means it's just going to go next dot next. And that's why the fast pointer is traveling 2 times faster than the slow node, right? So this is a very typical standard Floyd's algorithm cycle detection pattern where the fast pointer is traveling 2 times faster. And in the scope of linked list, this pattern is also very useful. So please keep this in back of your head, like this slow.next, fast.next.next, or using slow and fast pointer is very useful for linked list questions. So just keep that in mind, right? So now that we have traversed through the linked list, now how do we know whether there is a cycle? If you look at this example here, there is a cycle if the slow pointer so happens to reach to the first node being 0 index, so 2 here, and the fast node meets 2 as well, all right, this node, right? So what we're going to do is actually to check the reference of it, right? Slow equals to fast, then we know it's true. If not, what will happen is outside of this, we will just return false. Sorry, not fast, false. So basically, this is basically checking in terms of the identity of the class rather than the value of the class, right? So yeah, so this is not wrong. It's not intentional that I am trying to do equals equals. Equals equals represent to the value checking, but 3 pointer is pointing to the memory address, not the value itself, right? So please go and check that out as well. What's the difference between equals equals and triple equal sign to know the difference here. But this is the one that we are using to check whether they are pointing to the same node. But yeah, let's go ahead and run this. There we go. Let's try and submit this. There we have it. That is the solution. How do we prove whether a linked list has a cycle? We are using the Floyd's algorithm, where it consists of a fast and slow pointer, fast pointer traveling twice as fast as compared to the slow pointer. And if they meet in the pointer in the list node throughout the iteration, we know that there is a cycle in the linked list. And as I mentioned, like, please feel free to check out this on Google. There are a lot of helpful material out there that actually proves this algorithm. So do check that out. But yeah, that's all for today. I hope you guys find this video helpful. If you do, please feel free to subscribe and share this channel with your friends who are iOS engineers or Swift enthusiasts. I'll be posting more videos from here on now. And thanks for your time. Bye bye.